Hi, I'm Michael from A2A Simulations, and I'm the developer responsible for most of avionics in A2A airplanes. This is an overview of the autopilot in our APPR Aerostar 600, demonstrating how to use it and also some of its less known features. First, a little disclaimer. I'm from Poland, and if you find my English hard to understand, you can enable subtitles for this video. Or you can read the aircraft manual, which also covers the things explained here. And if you really like manuals, you will also find the links to real avionics documentation in our manual for further reading. Back to video. What we have here is a simulation of a Century 4 Autopilot as it was installed in the real aircraft owned by A2A Simulations. Much like our flight model and engines, this is also a fully custom simulation. What that means is that we do not use the autopilot provided by MSFS SDK, but rather we write our own code from the control logic to servo motors moving the aircraft surfaces. This is the way we've been doing it for many years, and this approach lets us bypass some of the SDK limitations. I think the first autopilot I did this way was the one in our B-17 Flying Fortress, which was about 15 years ago or so. Yes, time flies. The Century 4 itself is an autopilot designed in the late 1970s. And despite its age, it's a quite capable device with basic modes that should be familiar to those flying other aircraft in Microsoft Flight Simulator. It has several navigation modes like heading, nav, approach, reverse. And in the vertical channel, it can hold attitude, altitude, or follow glide slope down to the runway. With correct setup, the autopilot also can follow magenta line from GPS, as I'm demonstrating right now, flying on autopilot without touching any controls whatsoever. The primary source of information for the autopilot is the attitude indicator, and that provides pitch and roll data for the system to work. The HSI provides heading and course steering data. So these two instruments have to be operational for the autopilot to work. The altimeter is not connected to the autopilot, and its setting has no effect on altitude, as you can see right now. First, let's go over the controls, because these are scattered around the cockpit. On the central console, there are 4 switches. Master Avionics, that powers all avionics. Main autopilot switch, which powers up the autopilot, including flight director. Nav switch, select which instrument will be used by the autopilot in nav modes. In nav 1 mode, it will use the HSI and whatever controls HSI needles at the time. Whether it's VOR or GPS or RNAV unit, doesn't matter. In nav 2 position, things get weird. The autopilot will use course deviation from the VOR2 gauge, but it will still use course setting from the HSI. So you have to set the course on the HSI to match OBS on the second gauge, or the autopilot will not track correctly. So if you have 120 degrees here, you also need 120 degrees here. If you think this is confusing, then yes, it is. And the real Autopilot manual specifically contains a warning that the use of this switch is discouraged, at least in panel configuration like this one with HSI. But this switch was in the real aircraft, so we've modeled it in the simulator. And the last switch on the central panel is the auto train. That engages trim control for the autopilot. If this switch is off, the autopilot will use only this elevator servo for pitch control, which I will demonstrate later in the video. The main autopilot panel is located on the pedestal. The 4 buttons in the top row select lateral modes, and the 4 buttons in the bottom row select vertical modes. The buttons cancel each other, so only one mode can be active at a given time. The exception is glide slope button, which can be armed before glide slope capture, but for that we would need a valid glide slope signal. If you listen how the buttons click, these are recordings from the real aircraft. On the right, there is pitch wheel for selection of desired pitch in attitude hold mode. The wheel can be rotated by the pilot, but it also has a little electric motor inside, and it will sync to current aircraft pitch when the autopilot is powered on or when the attitude button is pressed. The button on the left toggles the autopilot on or off. There is also a small test button to test all the lights. Note that it also tests the attitude warning circuit, normally active only in glide slope mode. So the attitude light will be off, or it will blink depending on pitch wheel position. Next, we have a remote annunciator up here, so there is no need to look down to check the active autopilot mode. And next to it, there is GPSS switch to activate GPS steering. I will explain this function later in the video. This switch will be hidden without a GPS in the cockpit. Part of the autopilot system is also the flight director inside the artificial horizon. It appears whenever master autopilot switch is on, and it shows the current guidance generated by the autopilot control logic. And last but not least, there are also buttons on the yoke. Autopilot disconnect button is located on top of the trim switch. Beware that there is no audio warning that the autopilot has been disconnected. It just switches off. The flight director and steering modes still remain active. The second switch on the yoke is the pitch sync button, and this one is more interesting. It's located on the front of the yoke in the real aircraft, somewhere around here, so it's not visible in the simulator, and it has to be mapped in a certain way to make it work correctly. If you are using MSFS2020, you can launch our input configurator app and bind it to your joystick there. The app will be installed with the aircraft or can be downloaded from our website, depending on where you bought the aircraft. In MSFS 2024, the button can be mapped to your hardware right in the simulator, but it has to be done in a specific way. First, let's go to Controls, select your joystick, and search for A600. On the list, find Autopilot pitch sync press and release bindings. You want to bind your joystick button to the press action and then bind the same button to the release action. Now go to Advanced Options for release action, disable input repetition, and enable set control on release. Go back and save. I will show what the pitch sync button does later when I get the aircraft up in the air. But before that, I also want to talk a bit about the pitch trim. In real life, most autopilots control the aircraft like a human would, with servo motors connected to ailerons and elevator. Then, elevator trim is used to reduce the load on the elevator servo. And with our custom autopilot code, we can have both elevator and trim under autopilot control interacting with each other. So you can see when I engage the autopilot, the yoke begins to move following autopilot commands. If I set the new pitch, the yoke will pull up, and then the pitch trim will slowly follow. This may be a bit hard to notice in the Aerostar, but the trim needle keeps moving up. If I turn off the auto trim, the pitch trim control will be disconnected, but the autopilot will still be able to fly the aircraft, just with reduced effectiveness in pitch. In normal operations, the switch can remain on all the time, unless there is a malfunction in the system. If you forget to turn it on, you may notice that the autopilot has trouble holding the selected pitch or altitude. Now we're flying, so let's look at how to engage the autopilot, because it's a two-step process. First, set master switch to on. When you do that, flight director comes up and the autopilot guidance starts in heading and attitude mode, but you are still in control of the aircraft. You can activate other modes if needed, and when you are ready to engage the autopilot, press the on-off button on the pedestal. The autopilot will take over and follow the computed guidance as shown on the flight director. In other words, the master switch works pretty much like a flight director switch in bigger aircraft, for example Boeing 737. There is no warm-up or self-test period. The autopilot is ready to work at the moment you turn the master on. My advice is do not do that until you want to use the autopilot or follow the flight director. And when you engage the autopilot, verify that the flight director is centered, or at least points in the direction that you want to fly. For example, if I turn the master switch on when I'm climbing, notice that it syncs the commanded pitch to the current attitude. If I level off, the commanded pitch is still 10 degrees up. And if I engage the autopilot now, it will not stay at current attitude, but rather pitch up again to 10 degrees, as this is what was commanded on the flight director. Now let's go over different autopilot modes. The autopilot starts in heading and attitude mode. Heading mode works as you'd expect. It follows the heading back on the HSI. However, the autopilot is limited to 20 degrees bank, which is a bit less than the standard 30 degrees in other autopilot models. Attitude mode will hold the selected pitch. When activated, it will synchronize target pitch to current aircraft pitch, causing the pitch wheel to move to a new position. From there, you can move the pitch wheel yourself to make adjustments. Go around mode is just like the pitch mode, except it commands a predefined pitch angle. This mode can be used not only in go around situations, but also in cruise when you want to command a moderate climb. Out mode will hold the current altitude. The autopilot has its own pressure sensor, independent from the cockpit altimeter, and it does not have ability to pre-select target altitude. It will simply lock to the pressure altitude that existed at the moment you press the button. That means it's not recommended to press this button if your current vertical speed is higher than 500 feet per minute. I just did that, and you can see that the autopilot is not staying at the current altitude, but rather it slowly descends to the altitude it was when I pressed the button. The three navigation modes are similar to each other. They were designed to track VOR and ILS indications, and they all use the same basic logic. In these modes, the autopilot will use course information as shown on the HSI. It will take the course arrow setting to establish intercept angle and course deviation indicator, CDI, for steering left and right. The autopilot applies a fixed 45 degrees intercept profile. What that means is that if the CDI is deflected fully to the side, the autopilot will turn 45 degrees from the selected course. Then, as CDI comes back to the center, it will slowly reduce the intercept angle to 25 degrees. And at 10% CDI deflection, it will switch to tracking logic and turn to selected course. This is how the real autopilot works, and this profile is used every time you activate nav mode, no matter what is the distance to the beacon or what is the aircraft ground speed. The autopilot simply does not know that, so in some situations it may overshoot and hand the needle, especially if you are close to the beacon and flying fast. The approach mode works exactly the same. The difference is that the autopilot has different gains to better track localizer signal, but it is still using course setting and CDI to fly the approach. That means you have to set the course arrow to ILS inbound course, or the ILS tracking will likely fail, because the autopilot will receive conflicting information about the intended course and deviation. In approach mode, you can also activate glide slope mode, provided that there is a glide slope signal. If you are in altitude hold mode and intercepting glide slope from below, glide slope mode will arm automatically after around 10 seconds. But it is also possible to activate it from above or from different modes than altitude hold. Simply press the button yourself. As a safety measure, if the glide slope needle falls below 80% down deflection, glide slope mode will disengage and the autopilot will switch back to altitude hold. Reverse mode works the same as approach mode, but the autopilot will track the tail end of the needle. Instead of flying the course inbound, it will track the course outbound. The main use of this mode is to fly the localizer back courses or outbound VOR legs without the need to rotate the course setting 180 degrees. the autopilot will automatically compensate for reversed CDI movement. That fixed 45 degrees intercept angle I talked about in the previous chapter may be a problem in some situations, especially in an aircraft like our Aerostar, which can fly quite fast on approach. But there is a hidden mode that can help with that, which is called Selected Angle Intercept. To activate this mode, you have to press both heading and approach mode buttons at the same time. You can do that if you have them mapped to your hardware keys, or by clicking either of them with right mouse button. Both heading and approach buttons will lead. In this state, you can steer the aircraft with heading back and set a shallower intercept angle. The approach mode remains armed, and it will activate when CDI needle comes closer than 50% deflection. From there, it will work just like a standard approach. Another hidden feature of the autopilot, and I mean literally hidden behind the yoke, is the pitch sync button. The only way to use it is through custom keybind, as explained previously. This button is especially useful when you want to change the aircraft attitude or take control of the aircraft briefly without completely disabling the autopilot. When you press the pitch sync button, pitch mode will change to attitude, while lateral mode will remain unchanged. You will have control of the aircraft as long as you hold the button down. The autopilot will synchronize pitch reference to current aircraft attitude, and when you release the button, the autopilot will resume operation. For example, if I'm in altitude hold and I want to change the flight level, then instead of pressing buttons on the autopilot panel, I can just press the pitch sync button on my controller, push the yoke to set the new pitch that gives me the expected rate of descent, and release the button. That's it. Now I'm flying on autopilot again. Same with transitioning to level flight. Press the pitch sync, level the aircraft, release the pitch sync. Then you can switch on the altitude hold without disturbing the passengers. The last topic in this video is GPS steering, more commonly known as GPSS. I think the Aerostar may be the first add-on with GPSS simulated, and this has caused some confusion on the forums. In real life, connecting older autopilots to GPS is not as straightforward as it looks in the simulator. Most GPS units output steering data for the autopilot in the form of bank angle commands, so it can closely follow the so-called magenta line not only in a straight line, but also in turns, holdings, etc. But the autopilots made before the advent of GPS do not support that, and it is not just a matter of different protocols or data formats being used. Older autopilots do not have any place where you can plug that steering commands from the GPS. Imagine an old stereo unit without aux input. It may still sound great, but it won't play music from your smartphone. GPSS is an aftermarket option that solves this problem by converting GPS steering commands to fake heading back signal. This switch in the cockpit is used to control what is being sent to the autopilot. If the switch is in heading position, The autopilot will follow heading back, just like it would without GPS module installed. If the switch is in GPSS position, then GPSS module is in control, and it steers the autopilot according to GPS commands. In this mode, the heading back is disconnected from the system. Moving it has no effect. So using GPSS is quite simple. Program the route in your GPS, set the switch to GPSS, engage the autopilot in heading mode. That's it. If you want to return to manual heading control, set the switch back to heading and adjust heading back to desired position. GPSS has no effect on the autopilot behavior in nav, approach or reverse mode, but these modes can also be used with GPS, although in somewhat limited form. In these modes, the autopilot always follows what is shown on the HSI, and that is the course setting and CDI deflection. While these modes were originally designed to track VOR and ILS signals, they can also be used to track straight GPS route segments. If the CDI control is set to GPS, then CDI will show cross-track error data from the GPS. And assuming the course setting matches desired track, the autopilot will follow the needles just like it would for VOR. That's the one important thing that requires manual action from the pilot. If you're using nav modes instead of GPSS, then if the course setting is not set correctly, then autopilot will get conflicting steering data and it won't track. To sum up, here is a little cheat sheet describing what various combinations of switches do. If the autopilot is in heading and GPSS is off, the autopilot will follow heading back on the HSI. If the autopilot is in heading and GPSS is on, the autopilot will follow GPS magenta line. If the autopilot is in nav, then the autopilot will follow HSI course and CDI, regardless of GPSS switch position. Okay, that's all for this video. I hope you found it useful. Let us know in the comments. We have more tutorials like this one planned for the future. Cheers!